Hello everyone, my name is Zidyep Jonathan and I am finally engineering student of the Department of Metallurgical and Materials Engineering, Effort Institute of Technology, Kaduna, Nigeria. And that's if you're meeting me for the first time. So today we'll be talking about what is nanomaterials. So most of us might have heard of might have heard of the word nanomaterials, maybe in the class, or if you are studying materials, or you're just studying, or you just came across it in a newspaper or somewhere in your life. So now, what is nanomaterials? And according to the European Commission, the standard definition for it, which I'll be saying now, is nanomaterials is a natural, incidental, or manufactured materials containing particles in an unbound state, or as an aggregate, or as and agglomerates, and where for from 1 to 50% or more of the particles in a number size distribution, one or more external dimension is in the size range of 1 nanometer to 100 nanometer. Do not panic because I'm going to try to explain it. I know you might have started by, okay, what is this boy saying, but I'll try to explain it. So let's break down the definition. Number one, when he said nanomaterial is a natural, incidental, or manufactured, what are they trying to say by that? What do they mean by that? So number one, we're looking at nanomaterials can come from three places, which is what we are saying now. Number one, which is natural. So when we said nano, where they come from, number one, natural, we said they are formed in natural example. They are formed in nature. Sorry, they are formed in nature. So these are particles that are formed in nature. Like you don't need any chemical mixing. You don't need any chemical reaction. Not actually chemical, but you do not need any this thing, any creation this thing. Do you understand? You just need it happens spontaneously, like it happens on its own. Do you understand? Without any human intervention. So that's perfectly yes. Without any human intervention, that's how it comes to existence. And so, what are the examples of nanomaterials that are formed naturally? Number one is volcanic ash or sea spray nanoparticles. So volcanic ash is a type of nanoparticles, and also sea spray nanoparticles. All these are type of nanoparticles and they occur naturally. They do not need any human intervention to come to existence. And so also we're looking at incidental. So because we are looking at where do they come from? So that's what we're looking at. So incidental, produced unintentionally during human activities. So like these are nanoparticles that are produced unintentionally. They are not intentionally made, but they still have human intervention in their creation. Do you understand? And the natural do not have any human intervention, but that of the incidental, they have a human intervention, which humans are involved in the creation of these materials. So during human activities, examples of these materials are what? Nanoparticles from smoke or welding fumes. So smoke or welding fumes. Human beings, we burn things every day. We burn a lot of things, whether it's any, but things are getting burned every day. So from this smoke that I produce from things that we get burned, we do get nanoparticles from them too. So welding fumes. Carry out welding, the fumes that are produced from that welding is, or we also have nanoparticles from them, and you classified under incidental type of nanoparticles. So thirdly, you'll be looking at manufactured. So deliberately engineered by scientists. So these nanoparticles are deliberately, like they are intentionally made. They are not by mistake, as natural, which just happens to come to existence, and also the incidental, which just happens to come to existence by mistake. So this one, the manufacturer, they are deliberately made. And examples of them are number one, nanosilica, nanosilver, and carbon nanotubes. So these three are examples of nanoparticles that are intentionally made in the lab or wherever they do make them, lab or the clean room. Yes, they call the clean room. That's where they do make all these things. So, uh, looking at particles may exist in different forms. Particles in materials can exist can exist as unbound particles, aggregates, or agglomerates. So these nanoparticles that we just talked about, that might be natural, incidental, or manufactured, they can exist in different forms or different states. And we have three states that there is a possibility which these particles can exist. Number one is unbound particles. So unbound particles, individual nanoparticles separate from each other. So the individual particle, like we have two nanoparticles, they separate from each other. Do you understand? And they can exist in that state too. Number two, aggregate. Particles strongly bond together. So two particles bond together. They can exist in that state too as bonded. Like we have a nanoparticle together. They can also exist in that state too. So number three, agglomerate. So particles loosely stuck together. Like they are stuck together, but they are loosely stuck together. Like the force between them are not, there are weak forces, e.g. van der Waals forces or electrostatic forces. So these type of forces are the forces that might occur between two nanoparticles. So the most important part of the definition, a material is considered a nanomaterial if 1 to 50% or more of the particles, okay, like for example, for a nanomaterial to be considered a nanomaterial, you have to have particles that are in the nanoscales to be from 1 to 50%. Like it should be above 50% of the material. Do you understand? Like 50% of the material should be nanoparticles. That's when it can be considered a nanomaterial. You cannot. It does not mean if you just have only 10% of the materials being a nanoparticles and then you now classify it. No, it must be from 50% upward. So, how sizes between 1 nanometer to 100 meter? Have sizes between 1 nanometer to 100 nanometer. So we are talking about now. We explained last class what nano means, and we talked about how the sweet spot, which is from 1 nanometer to 100 nanometer, is the sweet spot. Do you understand? And we saw how below that we are entering the particle state, and above that we are entering the bulk state. So when we are talking about anything nano, we hear anything about nano, we are talking about, you should know that it's between the range of 1 nanometer to 100 meter. So these particles now, 50% of them must be within this range of 1 nanometer to 100 nanometer to be classified as a nanomaterial. So why do scientists measure particle size, not mass? So this is an important question. When I was trying to read it, I just tend to think, I was like, why why do they measure particle size, not mass? Do you understand? Like if they are talking about nanomaterial, they don't say the mass, or they say 5 kg of nano this thing. No, they measure it in nano. They measure it in nano this thing. They measure it in particle size instead of mass. So we tend to see that even these nanoparticles, even though they might be extremely small. Okay, nanoparticles are extremely small, so even millions or billions of them may weigh very little. But because there are so many particles, they create a very large surface area, and surface atoms control many properties like chemical reactions, strength, electrical behavior. So their impact is large, even though their weight is small. So so even billions, or like we can have nanoparticles because of they are small in number. We can have plenty of them. Do you understand? And their weight is insignificant. Like you might put it in a scale and it's too small to even show its existence. Do you understand? So if you say today that we are going to start measuring it in the mass, like we are saying start measuring the mass, where we are going to miss out on many nanoparticles because of how small most of them are. Do you understand? So that's why we tend to measure it in the nanoparticles, like particle size. Like we measure it by their particle size, not the mass. Because when we tend to measure in mass, most of them are extremely small to even show in a scale, but they still have large effect in it because of their large surface area. Do you understand? Billions and millions of them. It has effects on the materials, but it might not reflect as in the mass. Do you understand? So that's why we tend to sometimes, most times or all the times, tend to measure nanomaterials by their particle size, not mass. So I think with this explanation, you might understand this definition again. So I'm going to go about talking about what the definition said again. So now you might not be confused because I've explained the concept step by step. So the European Commission, they defined nanomaterial as a nanomaterial is a natural, incidental, or manufactured material containing particles in an unbound state, or as an aggregate, or as an agglomerate, and wherefore from 1 to 50% or more of the particles in the number size distribution, one or more external dimensions in the size range 1 nanometer to 100 nanometer. So this is an approved European made by the European Commission, and it's an approved definition of what nanomaterial is. So I think with this definition, you go back after watching this video knowing what nanomaterial is if you did not know what nanomaterial meant prior to this video. So thank you for watching, and remember, these videos are one take, so it's for learning. It's just a conversation we're having, and they're as imperfect as possible. I'll keep saying this every time because the goal is to improve communication skills and also to share what nano is. So I hope you enjoyed this video if you're watching it to this extent, and peace out, and I see you in the next video where we'll talk about the classification of nanomaterials.